Testing, 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 testing. 1, 2, 3.
Appreciate everybody for coming. So thank you very much. I'm Michael Maxey. I work with Zededa, and I'm lucky enough to host this very distinguished panel. I'm going to let them introduce themselves so you can get a little bit of their background, and then I'll come back and ask some questions. So, Oz, would you like to go first?
Sure. Hi, everyone. My name is Oz Sunai. I'm with Intel. I'm the chief architect for the Intel Tiber Edge platform that we announced as GA at NWC. I've been with Intel for about 2 years. I came to Intel through an acquisition. Before that, I was with a startup, and my background is in mobile communications. So I have experience in Bell Labs and Nokia.
Excellent. Eric?
So I'm Eric Nordmark, CTO and co-founder at Zededa. And I'm also in the Linux Foundation in LFEd, part of the technical advisory committee. And my background is sort of building software systems, I guess, from companies like Sun Microsystems, Cisco, Arista Networks. These sort of what technologies you bring to bear to actually solve problems, whether it's hypervisors or operating systems or whatever.
Awesome. Dave?
Yeah, hi, I'm Dave Booz. I'm with IBM. I've got my entire career with IBM, so it's getting on 37 years with the company. I've done everything from mainframe development, application servers, business process management, some stuff I'm forgetting about probably. Most importantly for today, one of the founders of the Open Horizon project, which is part of LF Edge. And that's what we'll talk about today. I'm a chief architect within IBM of a couple of products that use Open Horizon under the covers.
All right. So I was right. Very distinguished panel here. So thank you, guys. Dave, let's start with you. All right, let's start with Open Horizon. So when you invented Open Horizon, or when you were one of the founders of Open Horizon, what was the platform's North Star, and what technologies most impacted your design principles?
Yeah, so North Star and design principles.
Yep.
If there was one answer to that, I could give it to you, but there's actually been a few.
Okay.
So this is one of those projects where we started out thinking that IoT and data that IoT devices produced was something that could be monetized. So think about Weather Underground or any of the other kinds of ideas that were present in 2010, 2013, 2014 timeframe. We realized that it would be really interesting if we could find a way to combine containers, which were starting to become interesting in Linux being ubiquitous in small devices, what we would call the far edge today, okay. I think in general, and blockchain.
Okay.
And I can't say without laughing, because at the time we really thought it was a great idea where we could figure out how to deploy code to a containerized Linux small far edge environment and sell the data that it was producing. And turned out that didn't scale very well.
Okay.
So we changed our North Star.
The enterprises wanted their data?
Yeah, well, the enterprises wanted their data and nobody else wanted to buy it.
Yeah. Okay.
Right? So
even harder.
If you don't have either party,
yeah.
right, it's not going to work. So, everybody wants to talk about how their project had, very specific goals, and we got from A to B, and it's all great. We had to pivot at this point. So we're in 2015. We had to pivot and decide, okay, containers are still important. Embedded Linux is still really important. IoT is never going to be able to push the network the way it needs to get data off the edge. So we got to figure out how to process that data and make it valuable in the context where you're collecting it, right? And so that became our North Star. AI was starting to surface in that 2015, 2016 timeframe. So we pivoted the project and focused on distributed container deployment, which is what we do now, and distributed AI model deployment as well. And doing those with separate policy intent-based systems. And it was an experiment. And today, that's what Open Horizon has turned into.
Interesting.
It's a deployment platform for those technologies.
Cool. Very interesting pivot. Yeah.
It was.
Yeah.
And I can say, just to add, the day that I got to rip the blockchain code out of the code base,
yes.
that was actually a fun month. the blockchain was a nightmare. Turned out to be such a nightmare at the time, and so yeah, it was. We were glad to get rid of it.
Interesting. Cool. All right, Eric, let's stay in the past, right? Okay, so you helped create LF Edge back in 2018, 2019. Keep me honest here. How was the original vision held up? And then what's been surprising along the way?
So I guess the two things. One is sort of the technology that we felt that we needed, right? And as opposed to the problem we were going after. And the technology has actually changed a fair bit, because when we started, we thought that clearly this was all going to be deployed using low-end ARM processors, right? Because they were ubiquitous. They cost. We bought some for $7, right? So on the board, right? And you clearly needed to communicate east-west across the network. So you needed some secure overlay network. So we built all of this stuff, right? And then we realized that, well, no, but the business is actually running on Intel processors and industrial PCs or whatever, and deploying Windows, whatever it was at the time, whatever version of Windows, right? And that was sort of where the customers were. So let's figure out where we meet them. And so some of that technology was like, well, maybe this will show up later. But so that's one thing. But the other thing in terms of LF, and I think Roman Prosnik, who I saw somewhere back in the room here as well, he was actually involved a lot more in this stuff in the early days, but figuring out how to set the stuff up. But the notion that we will actually go in there and say, here's an open source project. It's a bit like, whatever, Docker, Kubernetes, right? Sort of like, we're going to get lots of developers here. Well, it turns out that when your sort of user base is not developers themselves, but the user base is people that are going to deploy this stuff in industrial settings, in energy settings, right? It's not quite the same user uptake that you would see elsewhere, right? Because it doesn't make sense for developers to run this on their laptop, right? It makes sense running it in the factory, in the plant, right? So that is sort of learning how does this stuff actually play out in terms of an open source community, and what does it mean to be an open source community when you're really talking to the OT side of things, the operational technology, and not necessarily to the IT and the developers. So that's one of the things we sort of learned as part of this journey. But the thing that I think has stayed with us is the set of problems we're solving, right? Edge computing wasn't a term when we started 7 years ago, but it was about solving the set of problems out at the edge in terms of running software, deploying, updating software, right? What's the life cycle? What security do you need, etc. So that stuff has actually stayed us all along. So
Interesting. So you got any comments on the developer pool is different in OT and
I mean, I think we've heard this from some of the other peer projects in LF Edge as well, saying, okay, are the big industrial companies, if they want to contribute to open source, they might not want to put their name on it because they've never done it before. So instead, they contract with some other company that actually does the open source contribution. That actually, so their name is not on the commits, right? Even though they paid for it, right? Because then this is, or at least was foreign to them a couple of years ago. So some of this stuff, like the announcement that was brought up this morning, right? In terms of these industrial companies like the ABBs and Siemens and Schneider Electric and Rockwell Automation getting together and saying, we're going to standardize on things with our competitors, right? In an open source setting. Like that means that a certain sort of maturity has happened there that I didn't think was there before, right?
Yeah.
So talking to these other players. So.
Right. It was very difficult in those, in the mid-10s in this century, right? Because the mindset at the time, especially for IoT development, is you're going to do something very specific to the device, to the hardware architecture that it has, to the programming language. Do they even have a framework that I can build this within, right? I mean, it was very daunting for most developers, I think, to even think about trying to put software into that context.
Yeah.
Right, which is why Linux and containerization is one of the key things that's going to help us move this forward.
Interesting. Yeah. So Project Margot, by the way, is the open source project.
Yep.
Yes. So it was let's talk a little bit about Intel. Like you guys bought off a lot, right? You have edge orchestration. You have OpenVINO, AI and ML ops, if I'm describing that correctly, and then a number of AI-powered applications, right? So I guess, why did you focus on these capabilities, and how did open source influence some of your design decisions there?
So Intel, specifically the NEX, Network and Edge Division at Intel, has been
as the name suggests, been dealing with enterprises and their AI needs for quite some time now. So the platform that I just mentioned, the Intel Tiber Edge platform, is actually unifying all these efforts, because those efforts were very end customer centric, and Edge being how diverse, they were almost like one-off solutions, appliance-like solutions. So we wanted to collapse all of those into, a horizontal layered stack, and then create the modularity and adaptability for different use cases and verticals, to share a solution that is repeatable, that is scalable, and that can expand beyond the first set of use cases an enterprise might have. And as they pile on new use cases, they can use the same platform with cloud-like simplicity.
Got it.
So that was the starting point for us. And orchestration is important. And I mentioned cloud-like simplicity, but Edge being Edge, really, when you think about it, there are multiple assets, specifically infrastructure, models, and applications that an enterprise or an SI that does it for an enterprise has to manage. And normally, when you think of the cloud domain or a lot of the edge solutions, these are compartmentalized, and we wanted to have a holistic view because they are very intertwined. An enterprise wants to be able to say, hey, this group of applications, I want them in all edge locations that fit this bill. And with a single click, be able to do that. That effectively means the inventory management of the infrastructure and its onboarding process and software provisioning has to be tied in with how applications are onboarded and how they are mapped. So from that perspective, orchestration and specifically, policy-driven orchestration became a central part of our platform. And then we had AI. Again, NEX had long experience on the AI needs of the early adapters within the enterprise space. And a lot of the early adapters actually focused on machine vision driven AI. So we had a lot of tooling for that. Now, so the findings that we had was AI is a different beast in terms of, whenever we talk these days about AI, we end up focusing on training. But from an enterprise perspective, it's all about inferencing. And when you're talking about inferencing, you can't just think that an AI solution can be deployed just the way a VM or a container is deployed. It's really different. There are three components for an AI solution. There is the code, there is the data, and there is the model. And all three are drifting. They are all, they have to be lifecycle managed. And when you deploy the same model across multiple sites at an edge, I'll give you an example, over time, that model is going to drift differently because of the location that it is running on. So you have to have the orchestration be cognizant of that. This is akin to saying, oh, I deployed a container, and now I have a gazillion different container versions of the same container that I have to manage. And how that is done, and how fine-tuning the model and inferencing needs to be tied, has to become an integral part of the Edge platform. There's no two ways about it, because we know acutely that enterprises want to use AI in their processes, in their operations, and we have to facilitate that. So the platform, from all the way from creating the solutions with toolboxes or giving them actually a full-on solution, for example, for defect detection that is customizable, and then operationalizing it, lifecycle managing it at scale is sort of the mission that we have.
Okay.
So because of that, solutions that are customizable and an AI optimized platform that gives a holistic view on policy-driven orchestration is what we ended up delivering.
Okay, very interesting.
I mean, it's clear that orchestration, or when you're doing this stuff in the cloud, it's a lot simpler because the hardware, you're presented with what looks like uniform hardware, right?
No, not at all.
Well, a lot more than at the edge, right? At the edge, it's a lot more diverse, but then, and as well as this different locations, we'll see different training, different data in their AI model. So it's going to evolve very differently.
I mean, when you think about edge, really, you're talking about diversity. So you can't really come up with a cloud out solution. It has to be an edge in solution. And Zededa has one, and we have one. And there it is. It's all about the diversity, and diversity is in multiple dimensions. The name edge means location, but that location indirectly means the size, the type of hardware, the type of workloads. And then you have the second diversity in terms of who's using it, who's the owner of it. And that dictates the type of security that you need, the type of latency requirements that you need, data sovereignty that you need. And then there's the application that has, depending on the application, I mentioned AI. If it is an AI application, it's a completely different beast. Then you have to support brownfield applications based on VMs, along with containerized applications. And you have to do this at scale across tens of thousands of locations. So it's a different beast, and you have to make sure that you create something cognizant of that, rather than forcing the cloud solution onto the edge.
Dave, you want to?
Yeah, no, I was just going to add to that. I mean, I everything you're saying is right, and it's a very difficult environment because in a data center we're very used to homogeneous compute. We're used to how that behaves at scale, et cetera. But edge also gives us, so it's different, but it also gives us some advantages, especially when you start to talk about security or even data sovereignty itself. We have some advantages with edge compute. If you can move the compute that you're doing closer to the source of the data, you have an opportunity to satisfy GDPR requirements, right? To enforce privacy from the end users. Using video to monitor what a worker is doing to help them be safe and help the equipment operate correctly is good for people. But it's not good if that data goes somewhere else, right? You get people in the background, you get that worker's identity itself. So if you can do more processing there and do it more securely and protect people while it's happening, right? You actually get some advantages by doing this and trying to embrace that context.
Yeah.
Right. It'll move us forward.
Yeah. So, I mean, maybe connected to that, you talked about vision. I guess we both talked about computer vision. What other use cases, like what are you seeing as IBM goes to market?
Yeah, it's anything. I mean, it's anything in the world around us. So there are ways to listen for things not working correctly in a machine.
Mm-hmm.
I mean, you can have a machine that's belt driven or chain driven, and if one of the ball bearings goes bad, it suddenly sounds different. We may not be able to detect it.
Yep.
A skilled worker probably can, right? Someone who's been operating that machine for 10 years.
It's the old car mechanic that starts by listening to the engine, right?
You drive it in, and I know what's wrong with it. I can fix it in 10 minutes. And you're like, I've been dealing with this for 3 months. So yeah, audio can do it, video can do it. Sometimes it's a matter of looking at the output of what the machine is doing, and you can tell that it's defective by looking at its output. I mean, the rate of bad welds that starts to occur. If you're monitoring welds visually, the rate of change starts to increase. You're rejecting more welds. Okay, there's probably a problem with that machine. Let's take it offline. Let's replace it. And you don't have to shut the whole manufacturing line down if you can catch something like that early. Right. So, I mean, there's a million applications for this if we can get a stable set of platforms and technologies for developers to be able to build these apps. And AI is where a lot of our smarts are going to come from.
Sure. Yeah, I mean, I was just going to say, with the rapid pace AI is moving. I mean, we just heard about Llama 3 just being released, but soon, very, very soon, they just announced that we are going to have in multiple t-shirt sizes AI solutions that are multimodal. So the same model is going to be able to support speech. It'll support machine vision. It'll support more conversation, stuff, all at once.
It's crazy. One model to rule them all.
And to be honest, I'm hoping someday we get a much better voice response system. I mean, who doesn't want to call their insurance company and have a better voice response system, right?
Yeah.
When you call in. So, that's got to get better too.
And for the edge, these models are very rapidly becoming very customized as well. I mean, I was just reading about the Microsoft small language model 5.3, and unlike the large language models, it's all trained on CS and EE textbooks. And guess what? It performs better than a lot of the large language models when it comes to code generation. No surprise there.
Yeah. Interesting. Okay. Let's stay with you. I read somewhere that NBC is going to be using your Intel Edge platform for the Olympics.
Yes.
So can you share more on like that use case and how it comes about and are you guys ready? Like that's a big event.
It is a big event. The short answer is yes. I mean, a lot of the tooling that we have as part of the platform, all the way from OpenVINO to Intel Getty, is going to be leveraged.
Okay.
And a lot of the silicon that we have, from AI acceleration with Gaudi to the latest Xeon, is going to be there. And it is not just one use case. It is actually, right now, there is 3 use cases that I know of, and we are busy building other ones. And that's, I'll tell you about the use cases in a minute, but when you think of the multiplicity of use cases, you immediately see why we have the platform running underneath. So there is a use case that I know of that is all about fan engagement. So an AI-driven use case where, based on, again, machine vision, the AI predicts a fan's motor skills and matches that fan into the best Olympics game that he or she could be successful at.
Yeah. Is there a programming option?
And then for Paralympics, there is an AI-driven sort of solution that we offer for visually impaired, sports person. And then the biggest grandiose thing is a software-driven broadcast solution that Intel has developed. And that platform does a number of things. First off, it allows the broadcast of 8K video streaming, and you can do outside broadcasting at scale from many, many vans, and in real time you can do content editing even through AI with Intel's Getty, so that different broadcasters can on the fly customize live edits and create customized content.
Wow.
So they can change who's winning? And this person
we're
crossed
not
the
there.
finish
We're
line
not
first?
there yet.
All right. Let's stay with maybe one more question around the open source, and then maybe Eric for you. Early decisions around EvoS. What's proven accurate for enterprise users, and maybe what wasn't so accurate?
I mean, I think that the thing that, and we're still sort of learning, but the thing that we invested early on in saying, we believe we need to make this stuff be as secure as we can, right? And I think that resonates with a number of different sort of users and use cases. There's other cases when people say, well, we don't care because we don't think we have those issues, right? And that could be because they're not sort of viewed as, critical infrastructure from their government perspective, or that they haven't been breached yet. But I think that that's something that actually is worked out quite well, and it's also a case when I think that the sort of users, they don't necessarily know what to ask for, right? Because for other things they might know that okay, I need to be able to deploy Kubernetes, or I need to have these real-time characteristics. It's something that they understand what that means, saying that I need the system to be 3.7 secure. Right?
Yep.
What does that mean, right? So I think that one has actually worked out well. Some of these other things, as I mentioned, right? To what extent do you need fancy networking? What does that actually mean, right? Is it overlay networks? Is it something else? And I think that we've sort of discovering this stuff as we go along. What does it actually mean to in the network environment where these things get dropped into is more diverse, just because it's out at the edge. But then what does that mean in practice, right? What do you need to support? Some of these cases that come up saying, oh, well, we're deploying this to first responders, and they're going to have 4 different LTE/5G modems with different operators because they need redundant connectivity.
Yep.
Like 4? Come on, 2 is not enough. So some of this stuff in terms of the technology and what you need to build to enable this stuff, it actually evolves as you discover more of these use cases. But overall, a lot of it is around that sort of like robustness, right? How do you make this platform as robust so that you don't have to go out there and have a person, press the reset button and power cycle the device, right?
Yeah.
What do you need to build to make that happen? And there's other people that are seeing this as being a challenge at the edge, and they figure out, how do I build a immutable Linux, not the sort of things you run on your laptop thing, but something that it boots the same thing all the time, right? So that stuff is something that's panned out as well.
Okay, cool. Let's switch to some quick reactions. So the first one is, so according to IDC, the analyst firm, the 2023 cloud service revenue was about $663 billion. The edge market is $232 billion. And the question is, will the edge market be bigger than the cloud market before 2030?
No, absolutely.
Yeah.
Yep.
Yeah, absolutely.
Consensus? Okay. So yes there. Okay. I like that answer. That's a good one. Thank you. The next one, so AGI is defined as the type of AI that can perform actions better than a human, right? So will this be achieved before 2030?
Most likely, no.
No. Okay.
But AI is going to be everywhere by 2030, and it's going to enhance and improve what we already have. It's not going to replace.
Yep. Okay.
I think that's a tough question to answer.
It's an impossible one.
It's a tough question to answer. And one of the speakers this morning actually alluded to part of the problem is going to be overregulation as well, right? So there's 2 parts to this, is when will we as humans decide that we trust it enough to allow it to be better
Got it.
than what we are willing to do, right? When does Terminator happen? Right? We don't want that to happen, but we're all talking about Skynet here.
Yeah.
I mean, ultimately. So yeah, by 2030, the governments are never going to be ready to let it be better, even if it is.
Okay. Interesting.
But I think, I agree on that part. But I think it's also sort of, people are looking at some capabilities. So clearly generative AI, right? We made tremendous progress in this. I think what we will see is, because generative AI, one thing it's doing is it's making people throw lots of money at this stuff, right? and investors, whatever, right? But that is actually, the effect of that is it's actually driving down the cost of doing this. So the cost of a GPU of a certain power capability, right, is actually dropping through the floor. So this means that in addition to what we're doing today, people will say, but wait, I now can do things I couldn't even dream of doing on something this big, right?
Yep.
That will now be possible. It will be inexpensive, right? So as long as people can figure out what does it mean to sort of develop models that make sense for them, we will see a ton more of AI across the board, whether it's whatever form it takes, right? So.
I mean, one thing to also realize is with AI development, the training that goes on, the need for energy is exploding.
Okay. Yeah.
Way before 2030, the amount of energy that AI training will need is going to be a very substantial part of the energy being generated. So there are bottlenecks,
Yeah.
even if we know how to get there.
Yeah. Interesting. Okay. Continuing on the reaction, what was the better series, The Lord of the Rings or Hitchhiker's Guide to the Galaxy? Eric, let's start with you.
Hitchhiker's Galaxy.
Yeah. Those?
Lord of the Rings.
Lord of the Rings.
Lord of the Rings.
Ah.
Okay.
Yeah. So we've each
Interesting.
alienated half of the room.
We got a
probably.
split panel. Okay, so we're going to give some stuff away, but before we do, let's get a hand for our panel. These guys are amazing. Thank you, guys. Very good job. All right, and then I think we're giving away Raspberry Pis. Excellent. High fives. Okay. I think kind of. I believe it's Julian you. Jalen, sorry, I'm going to blame Sarah.
Coming up.
It looks like Eisner. Sarah. I can't read your hand. It's Einer? Eisner? What's this one?
It's Miss
Einer Lopez.
Maybe we need an AI.
Raul Jirav,
Oh.
Eric Chung, and Raven Hodja. Sorry if I butchered your names, but congratulations. Thank you all. Please enjoy some more wine, some conversation. I really appreciate the attention today. Thank you guys. Great job.
Thank you.
And go back to the fun.
Yeah.
All right. Thank you guys.
Oh, pleasure.
Appreciate it.
See.